Hey everyone, Teacher Chang here, and today we're going to take a look at tangents in circles. So there's a couple of theorems that we're going to take a look at. And the first one says that if a line is tangent to a circle, then that line is going to be perpendicular to the radius of the circle drawn to the point of tangency. So what does that mean? So that basically means that if we have this tangent line right over here, then the radius drawn to that line is going to be perpendicular. So that's the main idea here. So we have a perpendicular line with the tangent line and the radius if that radius is drawn to the point of tangency. So we're going to be using that theorem, and we're going to be calculating the equation of a line that might be tangent to a circle. So here we're going to focus on this circle that has the equation of x plus 2 squared plus y minus 4 squared is equal to 25. Now, with this information, I now know what the center of our circle is. And our center is just at that point, H and K, which is located right over here. So this is H and this is K. So we go ahead and figure out, okay, well, what is our center? Well, our center is going to be located at this point at -2 and +4. Remember, it's going to be the opposite. So there's our center. So at -2, +4, we can find our center right over here. Now what I'm going to do is I'm going to be looking for the equation of the lines going through points C, A, and J. Now I'm going to go ahead and do A and J first, and there's a reason why. So what I want to do is I want to figure out a line that is tangent to the circle that goes through point A. Now from that theorem that we just read, we know that it is going to be perpendicular to a line in terms of the radius and the tangency line, or the tangent line, through the point of tangency. And in this case, it's going to be point A. So what I want to do is I've just created this tangent line in blue. And what I want to do is I want to figure out, okay, well, what's the equation of this line? Well, the nice thing about this is that this line is a vertical line. And when we have a vertical line, well, that just means it's going to be x is equal to, well, where does it cross the x-axis? Well, it's crossing the x-axis at -7. So x is equal to -7. And that's the equation of that tangent line. And we could do the same thing with J. So if we have a tangent line going through the point of tangency at point J, well, that means it's going to be perpendicular with the radius from the center to that point of tangency. So that means I'm going to go ahead and draw my line right over here, and here's our tangent line. Well, if that's my tangent line, well, that's a nice horizontal line. And to write out the equation of this horizontal line, well, that's going to be y is equal to the point where it crosses the y-axis, and that's going to be at -1. So that's the equation of a line that is tangent to the circle with the point of tangency at point J. So that's vertical and horizontal lines. It's going to be, if we have a vertical line, it's going to be x is equal to some number, and if we have a horizontal line, it's going to be y is equal to some number. But then I have point C. Now, point C is a little bit different because, again, we have a line that's going to be perpendicular with the radius at point C. So I'm going to go ahead and draw that line really quickly. I'm going to change the color here. So here we have our radius, and we know it's got to be perpendicular with a tangent line if the point of tangency is at point C. So I'm going to go ahead and draw that line right over here. But how do I draw that line? How do I know? Well, if it's here or if it's a little bit here, I'm not exactly sure. So what I need to do is I need to figure out, okay, since it's supposed to be perpendicular, I need to figure out, well, what is the slope of this radius that we just drew? Well, that radius is going to be 4 units down. So if I start at point C, I'm going to go 4 units down. So that's -4. And if I go over to the right, that's going to give me 3 units to the right. So the slope of this line is -4/3. Well, that means if I want a line that's perpendicular to it, I need the negative reciprocal, which means I'm going to flip it around upside down, so 3/4. And instead of a negative, I'm going to do a negative and a negative, which means it's a positive. So the slope of this new line, the line that is tangent to the circle, is going to have a slope of 3/4. So I'm going to go ahead and find out, okay, well, what is 3/4? So I'm going to go up 3 and over 4. Okay, so there's my new point here, and I could go ahead and connect those 2 points with this ruler here. So I'm going to go ahead and draw that. Oops, let me get rid of that line there. Okay, so here's my tangent line. And now I want to do figure out, okay, well, what's the equation of this line? Okay, so to figure out the equation of this tangent line, this is what we're going to do, is we're going to go ahead and use the point that we know, and that point is going to be at point C, and that point is located at -5/8. Okay, and we also know the slope of this tangent line. The tangent line has a slope of 3/4. That's what we just found out. Now, what I'm going to do is I'm going to use my point slope form in order to come up with my equation here. So if you don't know what point slope form is, I'm going to write it out. So point slope form is y minus y1 is equal to m times x minus x1, where x1 and y1 is a point on that line. Well, that's going to be my 5/8. So my -5 and my 8 is going to be my x1 and my y1. So now all I got to do is substitute. So I have y minus y1 is equal to m times x minus x1. And I'm just going to plug in my information here. Well, what is y1 in this case? Well, y1 is 8. And then our slope is 3/4. And then our x1 is -5. So minus a negative means a plus or a positive 5. So there's your equation. You could leave it like this. That is technically an answer because they just asked us for an equation of this line, and that is an equation of this line. But if you were asked to go ahead and write it in slope-intercept form, well, all you got to do is the math. So if we go ahead and do the math here, we just need to distribute the 3/4, and that's going to give us 3/4x plus 15/4. I'm sorry, 15/4 here. Okay, so now I have 15/4 is now equal to y minus 8. All right, so now all I got to do is I need to get rid of that 8. So I just go ahead and add 8 on both sides. Now, if I want to add 8, I want a common denominator. So I want to change that to 32/4. So that's going to give me 32/4. And then we could go ahead and get y by itself. So the 8's will cancel each other out on the left, leaving us with y by itself. We have our 3/4 x, and 15 plus 32 is going to give us 47. So we got 47/4, and this is your equation in slope-intercept form. So depending if your teacher cares if you write it in point slope form, like this one over here, or in slope-intercept form. That's up to your teacher. All right, so that's how we come up with an equation of a line that might be tangent at some given point. Now let's go ahead and take a look at another example here. So here we have a circle, and what we want to do is we want to figure out, okay, well, what is the length of AC and DC? Now, we probably should have stated that this is going to be a tangent line, and if it's a tangent line, we know that we have a right angle here. So BC is going to be tangent, where the point of tangency is going to be at point B. So BC, let's write that down. So BC is going to be tangent. So it's tangent with circle A. So the center is at point A. Okay, so since we know it's a tangent line, we know we have a right angle with the radius. Okay, so now all we got to do is to pull out that triangle here. So I'm going to pull out this triangle. And we have A, we have B, and we have C. So A, we have B, and we have C. And we have a right angle at B. Okay, well, from A to B, we have 5. From B to C, we have 8. And we want to solve AC. And, well, we could do Pythagorean Theorem here. So Pythagorean Theorem, a squared plus b squared equals c squared. Well, in this case, a is equal to 5, b is equal to 8, and c is our x. So that means we have 5 squared plus 8 squared is equal to x squared. Well, 5 squared is 25, 8 squared is 64, and 25 plus 64 is 89. And, well, to get x by itself, we'll just square root on both sides. And therefore, x is equal to the square root of 89. And if you want to, you can write it in terms of a decimal. So that's about 9.43. Okay, so let's say that AC is 9.43. Well, that's from here to here. But I also want to know, okay, well, what is DC? Well, that means I need to subtract AD. Well, AD is also a radius, just like AB. So that means this is 5. So all I got to do is 9.43 minus that AD, so which is 5. And if I subtract those two, I end up with 4.43. Okay. All right, let's go ahead and take a look at the next one here. So this is another rule that you need to know. The length of tangents drawn to an external point from a circle are going to be equal. Now, what does that mean? Well, that means the length from here, from A to this external point, and B to this external point, well, they're the same. They're congruent. So we can say that this side is equal to this side, or that length is equal to this length. All right, so that means these two must be equal. So if those two are equal, well, I'm just going to set them equal to each other. So 7x minus 1 is now equal to 20. And that's just basic algebra here. So we're just going to go ahead and add 1 on both sides. You add 1 on both sides. That's going to give us 7x is now equal to 21. And then we just divide 7 on both sides. And x is equal to 3. So that wasn't too bad. Okay. All right, not too bad there. All right, let's take a look at this next one. And we're going to use that same information that we talked about. So we do know that if we have a tangent line that is on the outside of our circle, an external point, that means these lines are going to be congruent. So this line and this line will be the same. So these two lines are the same, which means, well, if EB is 4, well, then that means FB is also 4. We could do the same thing going around. So if we have FC is 7, well, that means DC is also 7. So these two are going to be congruent. And we have the same thing on this last part. If AE is 6, well, that means AD is also 6. So these are going to be congruent as well. So they want us to calculate the perimeter. Well, that's simple enough. Perimeter of this triangle just means to add up the distance around each this entire triangle. So if we take a look, well, 6 plus 4, and that's going to give us 10. We have 4 plus 7, so from here to here, that's going to give us 11. So we're going to add 11. And then we have 6 plus 7, which is 13. So if we add those together, that's going to give us our perimeter. And well, that means the perimeter is going to end up being 34 units. All right, so that's what we need to know in terms of tangent lines and the point of tangency with a circle. I hope this helped out. If you have any questions, go ahead and leave a comment. Don't forget to give me a like and subscribe. All right, good luck, enjoy, and have fun.